of the things that the pancreas produces is a digestive enzyme called lipase, L-I-P-A-S-E. If it's produced by the pancreas, we call it pancreatic lipase. And that digestive enzyme is going to enter into the pancreatic duct, and it's going to be carried into the duodenum at the same time that bile is carried in. It's being carried into the duodenum because of cholecystokinin. When this fat globule reached the duodenum, it triggered secretion of cholecystokinin, which then facilitates the movement of bile and digestive enzymes. Now, bile is going to emulsify that globule of fat. It will break it down into smaller droplets, which are capable of being suspended within the intestinal fluid. You see, bile has a hydrophilic end and a lipophilic end. So the lipophilic end of the bile surrounds little pieces of that fat globule, whereas the other side, the hydrophilic end, dissolves within the intestinal juice. So it can break up that big old globule into smaller droplets, exposing more of the triglycerides to pancreatic lipase. Remember, pancreatic lipase is the enzyme, it's an ASE enzyme, that's going to break down lipids, in this case fat. So this process, where we go from the globule to the droplet suspended in intestinal juice, is called emulsification. And this emulsification has to take place before we can effectively chemically digest that fat. Okay. Remember that fat is made up of 3 fatty acids connected to a glycerol molecule. I'm just going to go in here. In a very simple way. Lipase is going to come along and cleave these bonds. Okay, converting first that triglyceride into a diglyceride. And then another lipase molecule will come along and cleave here, converting that diglyceride into a monoglyceride. And then you may have another lipase come along and break right here. So that in the end, you've digested the triglyceride into glycerol and fatty acids. Okay. These are small enough to be absorbed across the apical surface of these absorptive cells. So now, these different components that are in the lumen can pass through into the absorptive cells. Okay. So these absorptive cells, these are simple glomerular cells that are lining the villi that extend into the lumen. Now here's what's going to happen inside that cell. Now I'm just magnifying a single absorptive cell with its microvilli. When the fatty acids and the glycerol enter into the cell, they're going to be reassembled into a triglyceride, believe it or not. So inside the cell, we're going to reform triglycerides like this. These little triglycerides, and we're going to package them together and surround them with a coat of protein. Now, maybe that's much bigger than it really is. But this cluster of triglycerides surrounded by a coating of protein has a special name. This little packet is called a chylomicron. these chylomicrons are going to then be excreted across the basolateral surface of the cell through exocytosis.
It's chylo?
Chylomicrons, C-H-Y-L-O-M-I-C-R-O-N, chylomicrons. They're going to be excreted via exocytosis out of the cell, and then they're too big, these little packages of fats and proteins, they're too big to enter into the vascular capillaries. But remember that lacteals, or lymphatic capillaries, have larger openings. So these chylomicrons will enter into the lacteals. Okay. And form a fluid that's not called lymph in this case. It's called chyle. C-H-Y-L-E. So this chylomicron-rich lymph formed within the lacteals is called chyle. This chyle is going to pass from these lacteals, which are lymphatic capillaries, into the intestinal trunk. Remember your sequence. Reaching the cisterna chyli, which is the proximal part of the thoracic duct. The thoracic duct is then going to empty these chylomicrons into the subclavian vein on the left. So that is going to bypass the liver. That is going to bypass the liver. But absorption of fat, what we've learned, depends upon two things. It depends upon bile and pancreatic lipase. If either one or the other is missing, then fat is not going to be absorbed. You're going to have fat malabsorption. So, for example, if I have a gallstone that's blocking the common bile duct, okay, it's not going to prevent passage of pancreatic lipase, but unless that fat is emulsified first by bile, pancreatic lipase can't reach the majority of the lipid molecules. And so you're going to have fat malabsorption. That fat is going to continue down from the small intestine into the large intestine. Okay? And you're going to have fat-rich stools. This condition is called steatorrhea. Steatorrhea literally means fatty stools. Okay? Now, when that fat reaches the large intestine, some of that fat is acted upon or metabolized by bacteria. Okay? So it can produce gases. But that fat is very greasy. People who have steatorrhea tend to lose weight because they're not absorbing fat. People with steatorrhea will notice that their stools tend to float. Why? Because the stools are fat rich and they don't mix with the water in the toilet. Now, if the steatorrhea is due to obstruction of the common bile duct, then their stools are going to be clay colored, very light. Why? Because if you're blocking the flow of bile, then you don't have any bilirubin reaching the small intestine. And remember, within the small intestine, that bilirubin is converted to stercobilin. It's a brown pigment that gives stool its color. So if the steatorrhea is due to obstruction of the common bile duct, that patient with steatorrhea is also going to notice that their stools are very light colored, or what we call clay colored. Now, with that, will that patient with common bile duct obstruction have bilirubinuria? The answer is yes. They may present with jaundice, and the reason being is that the bilirubin gets extravasated as it builds up proximal to the obstruction, and that bilirubin that's extravasated re-enters the bloodstream. And so because this is conjugated bilirubin, it's water soluble, it will enter into the urine. Okay? So that person will have dark urine as well. So the jaundice that's caused by biliary obstruction is therefore different from the jaundice that's caused from a hemolytic anemia. With the hemolytic anemia, you would not see bilirubin in the urine because most of that is unconjugated bilirubin. On the other hand, with biliary obstruction, you would see bilirubin in the urine. Okay, so let's simply talk about the function of the liver. Oh, by the way, look here. This is a real micrograph. And so what you can see here is in the middle of the lobule, you have the central vein, and all these cells radiating out would be your hepatocytes. This is the lobule here. Here's a triad region. This would be a portal venule. I can tell right there that that's going to be a bile ductule. I don't see in this case an hepatic arteriole. These are sinusoids, these light-colored areas that are passing toward the central vein. This slide here simply demonstrates the sequence of vessels. Remember, you have an hepatic artery and portal vein. They empty into sinusoids, central vein, hepatic vein, inferior vena cava, right atrium. All right, we're going to end by simply mentioning the functions of the liver. We said production of bile. Bile is necessary for fat absorption. You not only need bile for absorption of fat, but also for absorption of fat-soluble vitamins. A, D, E, and K. Fat-soluble vitamins are only absorbed with the absorption of fat. So if someone has fat malabsorption, then they're going to lack those fat-soluble vitamins. You already know that the liver stores glycogen. Okay? During episodes of hypoglycemia, that glycogen is broken down and the glucose building blocks are released into the bloodstream. So the liver plays an important role in maintaining glucose levels. The liver synthesizes almost all, not all, but almost all of the circulating plasma proteins. You know, it produces, for instance, all the clotting factors. It produces albumin, the most abundant protein. Right offhand, I know, for instance, one of the few proteins it doesn't produce is immunoglobulins. Those are produced by plasma cells. But most of the circulating proteins are produced by the liver. So if you have liver failure, then plasma protein levels are going to fall. Oncotic pressure is going to fall. You'll become edematous. You'll develop generalized edema. Now, cholesterol can't circulate on its own. It's a big old fat that doesn't dissolve in the watery environment of the plasma. So cholesterol circulates in the form of packets called lipoproteins. And you may have heard of good cholesterol and bad cholesterol. Well, good cholesterol is cholesterol in the HDL, high-density lipoprotein packet, whereas bad cholesterol is LDL, low-density lipoprotein. But the idea is that the liver helps to regulate formation of these packets and circulation of these packets of cholesterol. The liver stores fat-soluble vitamins, whereas most water-soluble vitamins, with some exceptions, are not stored. They're simply peed off. And then one of the major roles of the liver is detoxification. For instance, if you drink a lot of alcohol, it's the liver that breaks down that alcohol. Same thing with drugs. As drugs are absorbed, they undergo that first pass effect and they're broken down. So it plays a role in detoxification. Finally, just to finish this page, the gallbladder, the only role of the gallbladder is to store and concentrate bile. It doesn't produce hormones. It doesn't produce any digestive enzymes. It's just a storage site for bile. It stores, and when I say concentrate, I mean it absorbs water from the bile, so it concentrates it. Okay? Again, when it's stimulated to contract by a cholecystokinin, it excretes that bile into the biliary tract so it can reach the duodenum. All right, here's what we're going to do next class. Next class, we're going to finish the second packet, and we're going to spend at least half the time looking at slides. So we're going to look at the stomach, small intestine, large intestine, liver, pancreas,